Back to this series on how to program in MOO. So the last video we talked about a lot of things. I'm going to try to keep these videos a bit shorter if possible, but really a couple things that you should know. A, it's a bit of a process to learn MOO. There are not a huge number of resources out there. Two, you're going to have to dig into the code yourself. So the best way to learn MOO is by looking at code that has already been written, and the best way to do that is to be in Lambda core and looking at verbs on objects. So if you do @verbs number one, you'll see, if you do @kids number one, you'll see a bunch of these children. There's a generic utilities package, and I really recommend you @kids that and look through all these packages. There's a lot of them. Some of them you're going to find useful, like string utils, list utils, wizard utils, math utils, time utils, maybe matching utils, object utils, command utilities, maybe building utilities, and definitely some code utilities. There are some other ones that aren't, at least I don't find as useful, but those are the ones that have a lot of the common functions you'd expect to find in a programming language, like help, string utils, trimming, converting a string to capitals, matching a string to an object, printing things in a pretty fashion with space, left, right, center. You'll find a lot of verbs on a lot of different objects that use this. So say you wanted to find something that used string utils left. You can do any of these, right? I don't know what check full does, but let's try it. Check full ASDF. All right, well, couldn't find anything. But if you look, you can find a lot of examples of these things being used. @grep is your friend, help is your friend. So in this video, we're going to talk about how to create a simple debugging system that will allow you to debug code, not necessarily errors, but debug the execution of your code. So imagine we've written a complicated verb that we want to easily debug at various points. We're going to create a verb, or we're going to create an object, create number one named Debugger, right? And we've created it. It's the object number 98. We're going to then corify number 98 as Debugger. So what this has done, if you watched the last video, you'll understand we can now reference Debugger like that. Now let's create a verb on Debugger called critical. And we're going to take any as the arguments. Sorry for that. And we're going to make it RxD. Now we're going to edit that. If you've set your local options, if you're following along, which I recommend you do, don't just copy and paste. You should really be typing these things out. It helps you to learn. Debugger critical. We now have this verb that we're editing in our web browser if you're using the web client, or maybe you're in Atlantis or VMOO. Hopefully you are not using the in-MOO verb editor because it's very difficult. You can always use @prog and just edit your code in Sublime and then paste it in. So what do we want to be able to do? Well, what we want to be able to do is call Debugger critical and pass in some arguments, ASDF, right? So you'll notice that ran because there is a verb, or there is an object called Debugger, and there is a verb called critical, but the verb has not been programmed. But we want that to output a string to us so that we know that there's some debugging going on. So what we're going to do is take arguments. So you can pass arguments into a verb. You could pass a string. You could pass a list, which is a list of other data types, even including other lists, right? Very quickly, you can have lists, you can have integers, you can have strings. There's no Boolean data type, but true or false is any 0 is false, any other number is true. You can also have error data types, so if you do like e none, there's no error. There's e verb not found. The MOO will raise these in, at various times. You can do try and catch around them if you need to. We'll talk about that in a later video. So we want to call this with all these arguments, and we want to basically display that to the user. So let's, to start, make it tell us. So number 2, that's our object. Number 2, tell, right? And then we'll call 2 literal args, right? So a couple things are happening here. We're referencing ourselves. Now this is just a temporary thing, so we're using object numbers temporarily, even though you should really use codified references. We're calling the tell verb. We're calling a built-in function called 2 literal, and we're passing args. Whatever's passed into a verb is going to go into the args variable. This is a list, which is very similar to an array. You could reference args1, args2, etc. Important to note that lists in MOO start with the 1 index, very similar to like Visual Basic back in the day. Most programmers are familiar with lists starting at the 0 index. MOO does not start at the 0 index. It starts at the 1 index. So just keep that in mind, because if you try to reference, you can test it here. We've got a list. 1, 2, 3. 1 is going to be 1. If I reference 0, I'm going to get a trace back. If I reference 4, I'm going to get a trace back because there's no 4th element. If I reference $, I'm going to get 3. $, is the end of the list. You could do 1 ... $, and get the whole list. You could do 2 ... $, and get those pieces, right? You could do $-1 to $, and get the last, right? Last 2. So let's see what happens when we do this. 2 literal args. So we've programmed it. It's programmed, and let's call debugger critical. We've been told this information. It's very nice. So 2 literal is a little bit different than 2 string. You can do help 2 literal, and you'll see it converts a string to its literal format. I'm sorry, it converts a list or an object or anything to a string, basically. You can do help 2 string and get nothing, and do help 2 str and get this. Now, if we were to do 2 string on args, it would work sometimes. Sorry, 2 str. It'll work sometimes. I don't know what will happen when we do that. We just get list. Can't really convert a string or a list to a string. You've got to convert it to a literal. Now, if we did debugger critical 1, right, it's still not going to work because we're referencing args. And args is always going to be a list, right? So if we look 2 literal args and we just pass 1 in, we're going to get a list because it's a list of arguments, right? If we pass 2, 3, we're still going to get 1, 2, and 3, right? It's still a list. So we've now created a very simple debugging method for ourselves where we can call debugger critical, and it will tell us whatever's there. So let's go back to our test object that we have, and let's check the verbs on it. We've got the put verb. Now let's edit number 97 put. It calls number 97 ADF. We don't need that, ASDF. Let's call debugger critical args. Well, let's do some stuff first. Player tell hey. Player tell done. Just a very basic example. Now if we call put ASDF in test, we get hey, we get ASDF, we get in, we get test. Is that what you thought was going to happen? Because all of this got passed, and it got broken up into direct object string, preposition string, and indirect object string. We could also reference just the dObject string, right? We could reference the prep string and the IOBJ string. And we get the same thing, right? ASDF in test, right? Now, you'll notice that we didn't pass a list to critical, we passed a set of arguments. But again, those arguments are interpreted by critical as a list because in critical, we are referencing args. We could do some list deconstruction or scattering, as it's called in MOO, but it's very similar to just object or array deconstruction in like JavaScript, ECMA script 2015. We could do A, B, C equals args. And then we could do toLiteral A. So if we put ASDF in test, we get just ASDF. However, if we do this, we get nothing. Now, let's see here. If we call debugger critical and we pass nothing, we get a traceback because we've got an incorrect number of arguments on line 1. So let's look. Line 1, we are trying to assign A, B, and C to args, which basically means A becomes args 1, B becomes args 2, and C becomes args 3. Args being a list of this format, right? Some value. But we don't have that. We just have an empty list. And referencing the one index of an empty list is eargs. That's the error it's going to throw. So we don't want to do scattering here. We just want to do a toLiteral. So we've now created debugging, but this is kind of long, right? So what if we wanted to debug what if we wanted to corify a specific verb, right? Because that is possible. Let's look at the properties on number 0. And let's see if we can find an example of a specific verb. Let's see. At show number 0.help number 60. At show number 0.failed match number -3. At show number 0.recycler number 63. At show there is a way to do it. I'm just trying to verb help number 0.verb help number 18. Now let me try. At prompt number 0.critical. We'll set it to number 98 and critical. At verbs number 98. Okay, well, I can't remember how to do this. At show number 0.newtlog number 70. Okay, I think I know how to do it. No, I don't. Sorry, I don't know how to do it. So, there is a way, just so you know, to set a verb, like critical, a reference to a verb like that. Let's see, at corify number 98 critical as critical. So, list number 98, list me at 4 or 5. Well, whatever. Moving on. We've now created a little debugging thing that we can use in our code wherever we want. So let's take a look at this in practical terms. So at list here look self. So number 3 defines the look self message, or the look self verb. When you type look in a room, the look self verb is called. When I look at my test object, the look self verb is called. To prove this, we're going to edit number 3 look self, and we're going to do debugger critical and we'll just critical out the args. So if I look now, critical, incorrect number of arguments. Did I not set that? Line 1 in critical, variable not found, 2 literal args. Whoops. So I see nothing special because I'm looking at an object. When I look here, I see this. Now that's not super informative, so let's change it to in look self. And now we're there, right? So this can be really useful for doing various different things. If you need to, say, this is just an example. Say you wanted to create something to allow any admin or any wizard to see the debugging information that was present. Instead of referencing number 2, you could reference them less directly. So let's use a for loop. For debugger in object utils descendants number, let's see, is wizard. Parents me. So number 57. So for every child of number 57, right? You know what? We'll do number 58. So for every child of that, and here's the difference. We're not just doing an at children on this, right? We're saying for every descendant. So for every child of the generic programmer, and every child of every child of the generic programmer, and every child of every child of every child of the generic programmer, we're going to execute some code. So for any programmer in the whole game that's connected, we're going to call this. We're going to say, we're going to call the tell verb on them and pass them this information, right? So for all intents and purposes, this should work the same way it already did. Except that if there were someone else logged in, they would also see that. So every child of generic programmer, and you can actually execute this at the command line, object utils descendants number 58, and you'll get a list back. This list right here. Now, you could look at every single one, like what is number 36, right? And you could see it's hacker, right? Or you could do string utils nn and pass the list in. And it will give you the name and number of all of those objects. You could even go a little bit further and say string utils nn and pass the function and get the same exact result, right? the evaluation line is actually really, really powerful. You can even do loops on it, right? So if I didn't want to create a verb for testing something, I could do for I in player tell I and for. Right? So what I just did there was I said for I in object utils descendants number 58. So for every descendant of number 58, tell me their object number. And I looped. So pretty much the same thing that's happening here, except right from the command line. Extremely powerful. Now, I want to talk a little bit about optimizations, right? Tasks take ticks, right? Every time you execute a task, it takes a certain amount of ticks. So help ticks remaining, I believe it is. Ticks remaining. Ticks left. All right. So ticks left tells you how many ticks you have left. For every thing that a verb does, its tick count is reduced by 1. And when it gets to 0, it will fail. Right? So if I did for I in 1 to 100,000 and 4, I think this will cause an error. Task ran out of ticks. Now if I change that 100,000 to 50,000, it works, because I didn't run out of ticks. So if we wanted to test how many ticks we had, we could do that. Concatenation of strings is done with a plus sign, just FYI. Oh no, a type mismatch. Why did that happen? Well, while tell will try to inherently convert any value to a string, before tell was even called, we were trying to do 5 plus a string. So what we need to do is call the toString method. Now, there's a couple different ways we could have written this. We could write it like this, where we're saying basically toString ASDF and 5, and we'll get ASDF 5, or we could do ASDF colon 5, ASDF colon space 5. We could also do the toString like this and get the same result. Now, how you do it is really up to you. It's a built-in function, so it's calling a C library underneath it, so it's probably pretty fast. The difference here is that you can pass as many arguments as you want, like that, strings, etc. So I tend to put it around the whole thing. You don't have to, but especially if you're making multiple toString calls on one line, it's probably a good idea to just wrap the whole thing in a toString. Keep in mind that I'm not concatenating anymore, so I'm not using a plus. I'm passing each one of these as its own argument to toString. So, just to prove that it works, we'll just do it on this one in the end. So let's try our verb, and we'll call debugger critical ASDF. So left at the start, 9,999 or whatever, 99,947. this caused some ticks to be used, right? In the end, we had 49,000 left, right? So if we wanted to get the usage, we could do what? Usage equals start minus end, player, tell usage plus toString usage. So we used 50,219 ticks to get to loop over this 50,000 times. So this used some ticks. This used some ticks. We used 50,000 ticks here. I'm sorry, no, we used however many 10 ticks here, some ticks here, some ticks here. We used 50,000 for this for loop. Now if we get rid of that for loop, we can see that it took 218 ticks. Not that bad. Keep in mind the MOO is single-threaded though, so while commands are running, other commands are not running. It's not asynchronous like Node.js. But one thing I'm noticing is that we call this toLiteral function inside a loop. So what if we didn't do that? What if we just had literal and we did it outside? Well, hey, we used fewer ticks because we assigned the literal to a variable and then just referenced that variable instead of calling that function over and over. So when you're benchmarking or seeing how fast your stuff runs, or when you run into situations where you're using more ticks than you want to or running out of ticks, the best thing to do at first is to look for places where you can optimize. So again, we've also, one other optimization I want to make here is we're referencing number 58. Well, if I do @chord number 58, maybe there is no @chord. If I @corify, let's see, builder, coda, programmer, prompts number 0, properties number 0. So there may be already corified a reference. So builder is referenced as number 4. There may be one for programmer, like the generic programmer. There may not be. But one optimization, not really optimization, but code optimization, if you're going to do things like that, would be to reference it like that. So let's call our debugger again. Oh no, tell notify lines. Descendants builder. I wonder why that happened. All right, we're not going to dig into it. We'll just set it back to what it was. So you can use ticks left to benchmark. Really good idea to at least program with ticks in mind. In a future video, I'll tell you how to replenish ticks and things of that nature. But for now, you've got a debugger that you can include in your code that will allow you to, at any point, basically console.log, if you're from the JavaScript world, whatever information you want to yourself or to a group of people that you want to see that information. That's it for this video. If you have any questions, add comments. If you like the video, please like it. I'll try to be less meandering in the future, but hopefully this was helpful for you.